In this video, we're going to find the interval of convergence for the following power series, and we do so by using the ratio test. So the limit as k goes to infinity of a sub k plus 1, so x to the k plus 1 over. Now you need to be a little careful here. I'm going to do it in two steps, k plus 1 in parentheses, the factorial on the outside. Now instead of dividing by a sub k, we'll just multiply by the reciprocal. So 2k factorial over x to the k. And let's see how this one is going to simplify. So we have the limit as k goes to infinity. This is going to be x to the k times x. And this is going to stay 2k factorial on top. On bottom, notice we have 2k plus 2 factorial. Now what would have happened if I didn't put the k plus 1 in parentheses, or I see a lot, people will just write 2k plus 1 factorial, and it's not quite correct. Although, in this particular case, it's not really going to affect our answer. X to the k. Now we need another step of simplification. So we have the limit as k goes to infinity, x to the k, x, 2k factorial. What we need to work on is rewriting this factorial, because we want to get that 2k factorial canceled out. Well, 2k factorial, the first term is 2k plus 2. The next term is 2k plus 1. The next term would be 2k, and then so on down. So that's where it becomes the 2k factorial, and then x to the k. This allows us to very clearly see our cancellations. The x to the k's will cancel, and now the 2k factorials will cancel. X is all that's left that does not depend on k, and I'll pull that up front along with the absolute value. And I've got the limit as k goes to infinity of just 1 left on top over 2k plus 2 times 2k plus 1, and I don't think there's any reason to FOIL out that denominator, because we can see what's going to happen. This denominator is going to grow, the numerator is not. This limit is going to go to 0, which automatically, because x is some number, is going to make this 0, which is always less than 1. This gives us an infinite radius of convergence and interval of convergence of negative infinity to infinity. This truly is our favorite case for power series, because it means that our power series converges for all values of x, and we don't have to test the endpoints. We're done very quickly. So if that limit goes to 0, automatically your radius of convergence is infinity, and your interval of convergence is all real numbers.